Today we are going to discuss a problem called lucky number using C++. You can solve this problem using any language like C++, C, Java, Python, whatever. But before that, we need to know what lucky number is. A lucky number is a number whose no digit is repeated. For example, say we are taking a number, say n equals to 3156. Here you see that is 3156 is a number where no digit is repeated. Every digit is unique, and that is called a lucky number. But if you take n is equal to say 6, 1, 6, 4, 5 or 6, here you see the 6 is repeated. So this number is not a lucky number. And number can be found by any number of digits. It may be say 357. It's a lucky number, 3-digit number. Or 616. It's not a lucky number, 3-digit number. So here our objective is to accept a number from the user and check whether the number is lucky or not. But how do you solve it? See, whenever you are accepting or receiving a number from the user, that comes as a whole and comes into our memory space. Say we are taking 357. So these 357 is coming as a whole. The digits are not separated here. So to check whether a digit is repeated or not, we need to extract the digits. How can we extract the digits? There is a simple solution for that. You can keep on dividing the number by 10. How? Say n is equal to, we are taking a simple example like say 353. So you start dividing the number by 10. Why you are dividing the number by 10? Because if you divide a number by 10, then you will get a single digit as a remainder. Say r is a remainder, so r is equal to 3. That is the first time when you are dividing the number by 10. And the quotient is 35. Division is the only procedure by which you are getting two answers. One is the remainder, another is the quotient. So you extracted the first digit 3 from the number, and you go back to do the same procedure by taking the quotient as the new value of n. So next time you are coming with 35, you divide it by 10, you get 5 as the remainder, you extracted 5, and your new number is 3 here, which is the quotient. So again, you divide that 3 by 10, 3 is the remainder as you cannot divide, and the quotient becomes 0. So your new number, that means n, is modified to 0. Once your n becomes 0, you can see that you have extracted all the digits present in the number. Okay. So this is the procedure where you can separate the digits from a number. Actually, you know that 353 is nothing but 3 into 100 plus 5 into 10 plus 3. That's why you have these digits are integrated here. You need to separate by special means like that we discussed. So you need to run a loop by which you can extract the digits one by one. But the question is, what do you do with that? The digits you extracted, but how can you check whether the digits are unique or not? The digits are not repeated or not. What you can do, you can take an array and put all these digits you extracted one by one. Say you are taking an array. Following our example, there are 3 digits present. So 3, 5, 3, these are coming here. Say the array name is A. We have 3 digits present. But the first problem is, what will be the size of that array? Because just I have told you that the number can have any number of digits. It may be a 5-digit number, it may be a 15-digit number. You don't know. So what will be the size of the array? Even if, say for example, we are considering an array of some size, and you have put all the digits present in the number one by one, then what will you do with that? How can you check whether any digit is repeated or not? You can do one thing by following a brute force solution. That means running a nested loop like that. Say a for loop is running within which another for loop is running, where every time with every digit starting from the beginning, you keep on checking whether it is repeated with the remaining digits present in the array. Say for example, I am taking another example, another number. Say we have 5171. So you see, there are 4 digits present in the number. We have extracted it one by one and start with 5. You have to compare 5 with the remaining digits and check whether 5 is there or not, 5 is repeated or not. If 5 is not repeated, you need to go to the next one and again you check whether this digit present in the second index is repeated here or not. In our example, this one is present here. So once you get a digit repeated somewhere, then you stop. There is no need to go further because you have got one digit repeated. Then you stop and declare that the number is not lucky. But if you don't get any digit repeated, you keep on moving until the last one what digit. Remember, you don't have to go to up to the last digit because last digit doesn't have any further digit to compare. So you need to go up to the last but one digit. You need to go up to that. That means if you have, I am taking another example, say 3, 5, 6, 9 are the digits present in a number. So you first check whether 3 is repeated here or not. Then you check 5 is repeated with the remaining 6 and 9. No. Then you check 6 is repeated here with by comparing with 9. No. And stop. But the problem with this nested loop is the time complexity will be of big O of n square. That is the big O notation by which we represent the time complexity. If you don't know this, you follow one of my video present in YouTube in my channel. But for simplicity, just I am telling you, if it is quadratic, that means if it is n square, then the complexity is high. So whenever you are going to solve any problem in your coding round during placement, though this code is easy, still you will see two things are very important. One is the solution procedure, another is the time complexity. You need to consider the time complexity also, because sometimes you will see even if your logic is correct, still you will see that some test cases are running and some are not. Why this so? You'll see a message might come saying that time limit exceeded. That means the problem actually is supposed to be solved within a specific time limit. But if your solution procedure involves something like that, that means that nested loop, then it may increase the time limit. Because of these, some test cases might not run. So you need to think about something, some clever solution. How this is possible? Let me enter into that. Say we know that in our number system, we have only 10 digits present from 0 to 9. Say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any number and every number must be formed by these digits present from 0 to 9. So here we are going to take an array of size 10. I repeat, of size 10, starting from 0 to 9. Why so? Come to the solution. Here, as we discussed, that we need to find out, we need to extract the digits present in the number by running a loop. Say we are running a loop. We discussed it. Say while n not equals to 0, that means until n becomes 0, you enter into the loop and check. Initially, you need to initialize this array by 0 value for all the 10 digits. And now you check if, but first of all, we need to find out or extract digits one by one. So r equals to, as we discussed, r equals to n modulo 10. You got your first remainder. Say for example, I'm taking an example, say 3, 1, 5, 3. So when you are dividing it by 10, you get 3 as a remainder. So R is 3 here. Now you check if SR equals to 0. Initially, all the values are 0. So do a dry run here. Say 3 is your first remainder that you got as R. Now you check if S3 equals to 0 or not. Yes, S3 equals to 0. That means this digit is coming first. There is no 3 before that. As you started here, definitely there will be no digit present. It is the first digit we extracted. So if it is so, you just try to indicate that you have got a 3. So how this is possible? Simply put something into that. Instead of 0, you replace 0 by something, anything. Say we are putting 1 here. So 0 is changed to 1. That means it will tell you later that you have got a 3 already. So the digit that you are extracting, you are using this as index, and going to that index, you are having an indication that you have got that digit already. So if it is not 0, then you are just putting up something else. That means you are replacing 0 by anything. Here we are putting 1. That will indicate that you have got a 3 already. Otherwise, else, what would this else do? See, that means you already got a digit somewhere. For example, say we are doing a dry run. So we got your first digit extracted. Now you have to get the quotient as a new number. So here it is 315. So come to that. Here you are having n equals to n by 10. So your 315 is the new n. Going back into the loop, say 315. Again you are dividing to get the next digit extracted. So R equals to 5 here. And also S5 is equals to 0. S5 is equals to 0. So you put 1 over here, 1 over here, and again you make your n change to 31. That is your new value of n. That is your new value of n. So you go back into the loop. I am not writing the else first because I am doing a dry run. 31 divided by 10, you get 1 as R. So R is equal to 1. And check whether S1 equals to 0 or not. Yes, S1 equals to 0. So you make it 1. That means you got 1. That will indicate that you have got one digit as 1. And again, you go back with the new value of n. New value of n is 3. So go back with that. 3 is not equals to 0. So again, you are entering into the loop and dividing 10, dividing 3 by 10, you get R as 3. And now you see, if SR equals to 0, if S3 equals to 0, no, S3 is not equals to 0. The value of S3 is already changed because you have got 3 earlier. That's why you have changed it from 0 to 1. So S3 is not equals to 0. That means there is a repetition. There is a repetition of 3. There is a repetition of a digit. So you are not entering into that if part, and once you get a digit repeated, you don't have to proceed further. You just go out by using that break statement. You just go out. That means a digit is repeated. You identify it. So this is the way you can check, you can verify whether a digit is repeated or not. So you come out from the loop without doing anything. And once you come out, a problem might occur. So how can you know that you are out from the loop from the else part, or you exhausted the loop? If no digit is repeated, you will never enter to that else part. You keep on moving until n becomes 0. So there might be a problem. How can you know? A simple solution is, if your n becomes 0, That means you have run the loop full. You haven't got any digit repeated, right? So if n equals to 0, that means your number is lucky, no digit is repeated, else it is not lucky, because you have come out from the loop midway. Because that condition is violated, you enter into that else part and coming out from the loop without proceeding further. So before the n becomes 0, somewhere you got your one digit repeated. Right. Now let's enter into the program. Here you see we are writing a program. First, you need to declare the variables. We are using I, N, and R. We are declaring an array, say, of size, not say it is fixed, because you have 10 digits present in the number system, and initialize them by 0. If you write 1 0, that is enough to initialize all the 10 locations in the array. Now you ask user to give a number, enter a number to check whether it is lucky or not. Enter a number, you are asking. Accept the number in n, and you do one thing, you just keep a copy of that n so that you will not lose the number, because while you are running the loop, you are continuously changing the value of n. So that n will be lost, the number the user entered will be lost. That's why we are just keeping that number copied somewhere. K is keeping that number copied, and you start running the loop. So while n not equals to 0 or n greater than 0, you enter and find out r n modulo 10, and now you have to check whether SR equals to 0 or not. That means you are checking whether that digit R is already repeated or not. If it is 0, you are changing the content of that location R from 0 to anything, just I told you 1, and then you keep on moving by changing the value of n. That means your quotient becomes a new number. And if not, that means if that digit is repeated, then definitely you will not find SR equals to 0. That must be changed earlier. If it is so, you are simply coming out from that loop without proceeding further. Now coming out from that loop, you just check if n equals to 0. That means the loop runs until n becomes 0. That means fully you won't get any digit repeated. That means it is not entering into that else part. It is not terminating prematurely. That means there is no repetition of any digit present in the array, in the number, I'm sorry. So you can declare that the number, it is already copied into K. So K is a lucky number. Otherwise, else definitely the number is not lucky, because you have come out from the loop prematurely by entering to the else part. So even before n becomes 0, you are coming out. So is not lucky. Save it and run it. Say we are entering a lucky number first. It is a 4-digit number, so it is a lucky number. And again you run with a variable, say a 3-digit number. It is also a lucky number. Now you check whether if there is any repetition of a digit, say a digit is repeated here, 4 is repeated here, you see it is not lucky, because for the first four, the S4 location, you are changing the value from 0 to 1 into the array S. So whenever it is getting the next 4, it is getting that S4 is not 0. So it is coming into that else part. You can see that it is coming to that else part. And you are coming out from the loop prematurely, and n is not 0. So it is not printing lucky, rather it is printing not lucky. That is the logic of solving the problem. You can see that you are running a while loop, no nested loop. So its complexity is linear, and it would be big O of n. So it is time efficient, though the problem is easy, but it is a famous problem. I think you understand this, and keep on following my channel so that you will discuss some medium level problems also